So today we're going to discuss linear functions. Something we should be familiar with is our traditional slope-intercept form, but we're just going to add in this functional notation. So we're used to the y equals mx plus b form, but we're going to add in this function notation, which is basically just saying when you plug in x into f of x, we're going to treat this the same way. So just a few review things. We know m is the slope. But what really is important about the slope is what it tells us is that for each change in the input by 1, right? If we increase the input by 1, the slope will tell us the change in the output. B, our vertical intercept, tells us the initial value, and this corresponds to when the input is 0. The next important definition that we want to discuss, or formula that we're going to need, is the slope formula from 2 points. Hopefully it's reviewed that if we're seeing it as some coordinate pair, we find the slope by doing y2 minus y1 over x2 minus x1. But if you look here at our function notation, instead of y, we have f of x. And so that's where this additional slope formula comes from. So let's start with an example. We've got a pair of points here, negative 2, 1, and 2, 3, and we're trying to write slope-intercept form, or we're trying to write the equation y equals mx plus b. So what we've got here is 2 points, negative 2, 1, and 2, 3. So let's label those points as our x1, y1, x2, y2. And the two things we need are the slope and the y-intercept. So let's start first. We have a formula for slope. That's going to allow us to get m. M equals y2, which we've labeled as 3, minus y1, which we've labeled as 1, over x2 is 2, minus x1 is negative 2. So 3 minus 1 is 2, over 2 minus negative 2 would be 4. So we get 2 over 4, which reduces to 1/2. So far we know m is the same thing as 1/2. So replacing that into our formula, remember we need an m and we need a b. We have y equals 1/2 x plus b. So the only part of this formula we need left to find is b. B corresponds to the initial value, or when the input is 0. Well, in neither one of these functions is the input value, the x, actually 0. But we do know that if we plug in x and y, we can work backwards to find b. So you can pick either one of these points and work backwards to find b. If it was me, I would pick this 2, 3 point because both of them are positive numbers. So what we know is y is 3 equals 1/2 times x is 2 plus b. So 3 equals 1/2 times 2 is 1 plus b. If we subtract 1 over, then what we get is b equals 2. So now we have m and we have b. We can write our equation y equals 1/2 x plus 2. Now here we're looking at essentially the same type of function, but we have functional notation. We're going to write this as a linear function, which means we're going to try and write f of x equals mx plus b. And so we have f of 4 equals 1 and f of negative 4 equals negative 5. Well, in functional notation, we could actually think of that as a coordinate pair, x comma f of x. And so f of 4 equals 1. I'm going to let that be my x1 and f of x1. And so here the input x is 4 and the output is 1. So 4 comma 1 is technically a point, and in the same way we can do this over here. -4, -5 is also a point. So this is technically my x1 and f of x1 and my x2 f of x2. And so we're going to begin by finding m. M equals -5 minus 1 over -4 minus 4. And so what we get is -6 over -8, which we should recognize actually reduces to +3 over 4. A negative over a negative would give us a positive, and we reduce that fraction to 3 over 4. So far we have f of x equals 3 over 4x plus b. And similar to how we did last time, we're going to work backwards to find b. So I'm going to pick my f of x as one of these points. I can pick either one, so I'm going to choose 4, 1. And in the case of 4, 1, f of x corresponds to 1. So 1 equals 3 over 4 times x is 4 plus b. So 1 equals 3/4 times 4 would give us 3 plus b. If we subtract 3, b equals -2. So now we have our m and our b, and we can write the function f of x equals 3 over 4x, and since it's plus b and we've got this -2, I'm just going to write that as -2. So the last thing that we want to recognize is how can we pull out the y-intercept and slope if we don't have slope-intercept form. And so what we want to do is somehow write y equals mx plus b. In other words, we're going to try and somehow solve for y. So what I want to do is get this y here by itself. And we're going to do that algebraically. We know in algebra, as long as you do something to one side, you can do it to the other side. And since I want to get this as mx, what I'm going to try and do is move this 3x over here so that it looks the way that I want. So if it's a positive 3x, I'm going to subtract 3x. And there what we would have is 2y equals -3x, and this is a positive 8. Then since it's 2 times y, and we want to undo that multiplication, we undo multiplication with division. And I can divide both sides by 2 as long as I divide everything by 2. And so y equals -3 over 2x plus 8 divided by 2 would be 4. So we know now the slope, which is the same thing as m, would be -3 over 2, and the y-intercept would be the positive 4. Okay, over here we're trying to do the same thing again. We want y equals, and so what I would say I would notice is that I can move 2x and positive 8 over there by doing the opposite of them. So what I'm going to do is I'm going to subtract 2x and 8 from each side. And so -4y equals -2x minus 8. And then similar to the example before, if it's -4 times y, I'm going to divide everything by -4. So y equals -2 over -4 would reduce to 1/2. And -8 over -4 would reduce to +2. So in this instance, the slope would be 1/2, and the y-intercept would be +2.